Good morning, ma'am.
Good morning.
Good morning, ma'am.
Yes, so we will start in just 2-3 minutes. I I guess your lecture is over just now. So just take 2-3 minutes of break and then we'll continue.
Okay, ma'am.
Okay, so let's continue with our lecture. So in the last lecture, we had started with NFA, right? We had started with NFA. So what's the difference between NFA and DFA, guys? Is there a difference or they are the same?
Yes,
I
ma'am,
mean,
there is a
DFA
difference.
for
Yes.
in DFA for each state, you can only have two transitions for like one input, like one transition for one input each. While in NFA
Yes.
there is no restriction.
Yes, very good. So in NFA, there is no restriction, but in DFA, there is a restriction that you can have or two states, or we can say that we can just have a single state over there. But in DFA, you can have multiple states. Now, what are these multiple states? Those are given by something called as Epsilon closure. What is this Epsilon closure? Okay, we'll just have a look into that again, and then we will take few examples. Okay, so is my screen visible?
Yes, ma'am.
Yes, ma'am.
Okay, so yeah, we will start that. Yeah, and I have also uploaded the PDF of the ebook. Have you guys got it? Is it available or should I upload it again? Yes, if I think
Check करके.
Martin's. हाँ, check करो एक बार. अगर it's there, then that's fine. Otherwise, I can share it again. Okay. So we had started with NFA, right? Now there is a difference
It's there,
between
ma'am.
DF. It's there?
Yes, ma'am.
Okay, good. So just give me a few minutes. Okay, so we had started with DFA. So the difference was that, suppose let's see DFA and NFA again. The difference, I had given this, I think most of you have written it also. Okay, so in DFA, basically, if you have a state with an input, there can be a single state only which is accepted. Single state which is accepted. Whereas in NFA you can have multiple states; those are accepted. Okay, multiple states can be accepted. So here we can say that in DFA you just have single computation, you have single computation, but in NFA, you can have multiple computations. That's the major difference between DFA and NFA. DFA and NFA. Okay. So let us have a formal definition of that. What is actually the DFA and NFA? Okay. Now we will see the formal definition of NFA. So NFA is also a five tuple, similar to DFA, right? NFA is also a five tuple, similar to DFA. So the definition of NFA goes in this way. Okay. So basically a non-deterministic. Why is it called non-deterministic? A non-deterministic finite automaton. A non-deterministic finite automaton, NFA, is the five tuple. Okay, it says that it is the five tuple and it is given by, everything is same to DFA, only the difference is the states, right? And it is given by N is equal to Q sigma delta Q naught and F. Okay, where Q is the finite set of states. We know that Q is the finite set of states. Sigma is the input alphabet, and input alphabet can be either 0 or it can be 1 or it can be A. What else? It can be A, comma B, etc. etc. Then this delta is your transition function. Delta is the transition function. Q naught is the initial state. Q naught is the initial state, and F is the final state. That is how it goes. But the major difference over here is that, for example, for a set A, okay, for example, if I'm having a set A, so for set A, 2 raised to A will denote. 2 raised to A denotes the power of set A. The power of set A, right? This is how it goes. Now, there is a different concept over here in NFA. That concept says that it is epsilon closure. There is a concept of epsilon closure. Now, what is this epsilon closure? It should be very clear to us. Epsilon closure, it means that there can be n number of transitions, you can say, epsilon transitions, okay? So, epsilon transition, or epsilon closure, the definition is the epsilon closure of a state. Okay, I'll just write it. The epsilon closure of a state, the epsilon closure of a state Q is the, okay, you can just write down the definition. The epsilon closure of a state Q is the set of states, reachable. Okay, set of states reachable from Q, reachable from Q through epsilon moves. Okay, through epsilon moves including itself, through epsilon moves including itself. So this is how it says the definition of epsilon closure. Okay, now when I'm talking about the difference between DFA and NFA, we all know that the major difference between DFA and NFA is that of epsilon moves. It means multiple, you can have multiple computations present over there, or you can have multiple states present over there. That is the major difference between a DFA and NFA, right? So the formal definition, we know that it is a 5-tuple and it is given by n is equal to q comma sigma comma what else it was this, okay. It can be given as q comma sigma comma delta q naught and f. It is a 5-tuple, and what it stands for, we know that also. The major difference over here is that power set, okay. So for a set A, 2 raised to A denotes the power of set A, and then we have very important concept over here which is called as the epsilon closure. An epsilon closure of a state q is the set of states reachable from q through epsilon moves including itself, okay. Now let us take one example, a small example for you to understand this. Last lecture we had also taken one example, but we will take some small example now today. Okay. Now consider, so for example, we will take a quick example. Okay. Now consider a state transition diagram like this. For example, if I'm having a state transition diagram with the states Q naught, I'm having one more state, Q1. And then what else? I'm having one more state, which is my final state, that is Q2. So I am having 3 states here, Q0, Q1, and Q2. This Q0 is my start state or the initial state. The transitions I'm having is this 0. Okay. Here, for example, I'm having epsilon. Over here from Q1 to Q2, I'm also having one epsilon transition, and I'm also having one. And for example, mm, let's consider this to be 2. Okay, this is just for your understanding. I'm not giving the actual input in the form of 0 and 1. Is what this means. This NFA, this is an NFA. Okay, this is an NFA. Why it is an NFA? The difference between that, because it can. Yes, anybody? Why it is called as an NFA?
Because, for example, in Q2 there is only one the thing coming out of it, and that's
Yes.
not allowed in a DFA. You need to have at least 2 transitions. There are only one transition coming out of Q2,
Yes, very
and it
good,
has epsilon moves,
Anshul. Yes, one. Anything else?
and it also has epsilon moves.
Yes, and it also has epsilon transitions. Very good, Anshul. So this is your NFA. And it says that there are 3 states, Q0, Q1, and Q2. And I'm having 3 transitions present over here from which goes to itself, okay, 0, 1, and 2. So my input here, for example, my inputs are 0, 1, 2, okay? Okay, 0, 1, 2. Then what about the epsilon closure of? Now don't get confused with this 0, 1, 2, because generally we always use for this formal languages and automata theory, we always have 2 inputs, 0, 1, or it can be A, B. This is just for understanding, for you to understand. Okay. Now first one, let's calculate the epsilon closure. Okay, we have done this. Now we have to check what is the epsilon closure of this. Okay. Now epsilon closure, first one, we will calculate the epsilon closure of Q naught. Okay, how it goes? Epsilon closure of Q naught. Okay. Now initially I am present in my first state or my initial state Q naught. Okay. So what will be my epsilon closure then? Q naught goes to Q1. Okay. Q1 goes to Q2. Again, you have Q2 present. What it means that in epsilon closure, read the definition. Epsilon closure of a state Q is the set of states reachable, okay, from Q through epsilon moves, including itself. It means what? It will include this epsilon closure of Q naught. It will include itself, that is Q naught. Again, it is reachable to which states? Through epsilon moves, This is the epsilon moves. We are having two epsilon moves present here, right? So Q naught to Q1 for this epsilon mu, I'm reaching Q1. Then from Q1, I'm having one epsilon move. I'm going to Q2, right? Is it Q naught, Q1, and Q2? This is my epsilon closure of Q naught. Is this clear?
Yes, ma'am.
Now, similarly, if I want to calculate the epsilon closure of Q1, so that will be, I will start with Q1 because it says that, read the definition. It says that epsilon closure of a state Q is the set of states reachable from Q through epsilon moves, including itself. So for epsilon closure of Q1, I will include Q1 itself, and I will check the epsilon moves from Q1. So from Q1, I'm having one epsilon move, which is going to Q2, right? So I will write Q2 here. So this is the epsilon closure of Q1. Now suppose I want to compute the epsilon closure of Q2. Now you tell me what will be the answer of this.
Q2.
Q2.
I'm only Q2.
Very
Q2.
good. Yes. So the epsilon closure of Q2 will be Q2 itself. Okay. This is how you calculate the epsilon closure of given states. Okay. But the definition should be very clear to you and it should be fit in your mind that what is the definition? It is epsilon closure of a state Q is the set of states reachable from Q through epsilon moves, including itself. So this is your final solution for the epsilon closure. Now what we will do is let us quickly take very few examples. Okay, we will quickly take few examples. So are you guys noting this or what? Or should I proceed?
Yes, I'm done.
Okay, done. Good. So let me just take you to, we'll just compute another. Okay. Now let us take one example over here. What will be the example here? See, take your first question. Just write down your first question. The question is the question is construct a NFA, okay, that accepts, construct a NFA that accepts all strings that begins with 0. That begins with 0. See, this is the question which is given to you. The question says that construct a NFA that accepts all strings that begins with 0. So
An
how will you
alphabet?
do that?
What's the
Yes.
alphabet?
What happened?
Now, over which alphabet?
Okay, over which alphabet? It's not given. For example, if it
Okay.
is not given. Okay.
So we can only use
Hmm.
0.
Hmm. And what else? We
So
always have
1.
to use 1 also. Okay,
Okay.
guys, getting this? Whatever the question is, you should always use 0 and 1. Show both. So it is not given to us. So let us just write down the language. What will be my language over here? It says that construct a NFA that accepts all strings that begins with 0. So it means the string 0 will be accepted. Yes, the string 00 will also be accepted. 01 is also acceptable. Then 000 and so on. So this is my infinite set. Okay. So this is what the inputs which can be accepted. Either it can be 0 or it can be 00 because the condition is that it should begin with 0. The condition is that it should begin with 0. Okay, getting? So over here, either it can be 0 or it can be 00, it can be 01 or 000. It cannot be 10. Are you getting this? It cannot be 10, 11, etc. Because it should begin with 0. That is the condition which is given in the question. So these are our values which should be available. Now let us draw a state transition diagram for that. So I'm creating my initial state A. This is my initial state. Okay. What is the question? It should begin with 0. So that's pretty simple. I'm sending a 0 to my next state, that is B. Okay, my next state is B. Okay, okay. And now on B is my final state. And so B can have either 0 or it can have 1. It means what? It can read out to be, B can have either 0, 0, 1. Okay, B can either have, no, not like that. B can either have 0, 0 or B can have 0, 1 finally. But the condition is satisfied that it begins with a 0. That's why I'm giving two inputs here, 0, 1. Now, you may have a question here. In DFA, we were always showing what we were showing is both the inputs 0 and 1. Okay, is this clear? We were always showing both the inputs 0 and 1 and the transitions where that is going. Okay, that was necessary for a DFA. For a DFA, that was necessary to show both zeros and ones. But in NFA, there is this is eliminated. There is no necessity for showing all the inputs. The only condition should be satisfied. So, are you getting this? This is our NFA. This is our NFA. Any questions in this? You can ask. Okay, I guess no questions. Then I'll proceed further. Okay, is it clear?
Yes, ma'am.
Okay, now let us take example. Suppose you have example. Now we have to check now whether it is working or not. So for example, 0, 0, 1. Tell me whether it is accepted or not. So we will just draw over here, just see whether it's working. Okay, initially I'm in my initial state A. Then on getting 0, I'm going to my next state B, right? Then again, on getting my next input 0, I'm present in B itself, right? So I'm going to B itself. Then on receiving 1 also, on receiving 1, I am going to B again. What is B? B is my final state. Okay, and at the end, after giving all the inputs or after sending all the inputs, I am present in my final state. Therefore the string is accepted. We can say that the string is accepted. Now we will see another condition. Now for example, uh, okay, just consider your next one is 1, 0, 1. So whether it is accepted or not, tell me. Yes,
No, ma'am.
it's not
No, ma'am.
accepted because yes, because we do not have one. Okay, we do not we have not shown where one goes on A from A, right? 0 goes to B, that we know, but we do not have one here. It is absent. So it won't proceed further. It's not accepting. So instead of that, it will go to a null state phi, and this is called as a dead configuration. This is called as a dead configuration. Okay. So this was NFA. Okay. This was NFA. You could show a dead configuration, but in DFA, we did not had dead configuration. Instead, in DFA, what we had in DFA, we had dead state, right?
State.
Yes. In DFA, we had dead state. Now let's convert this NFA to our DFA. Is this clear? It is not going anywhere. So it is in the null state. Okay. It is present in the null state. It is nowhere. So that's why a phi represents a null state. And this is called as a dead configuration. Therefore, not accepted. Therefore, it is not accepted. Now let's convert this. How do we convert this DFA to NFA? Sorry, this NFA to DFA?
We make a dead state and we send the one input from A to that dead state.
Yes, you are absolutely correct. 0, I'm keeping this as it is. And one more thing I need to add over here is that I will make a dead state here. For example, C, because I have to show now where 1 is going. From A, I have already shown that 0 goes to B, but where 1 goes. So that's why this is my dead state C. And C can have any values of zeros and ones. This is my dead state. Okay, dead state. So this is how you convert a given NFA to a DFA. And this is our DFA. Is this clear?
Yes, ma'am.
So one point to remember over here is that in NFA, we do not have a dead state, okay? In NFA, we do not have a dead state. We do not have a dead state, but we have what? We have dead configuration. We can show a dead configuration like this by epsilon, okay? Sorry, by phi. Phi is the null state, but dead configuration is present in NFA. Dead configuration is present, whereas in DFA, we have a dead state. That's the difference. We have a dead state. Okay. Now I hope this is clear. Okay. And one more thing to remember is that this dead state is also called as a trap state. You can also call this dead state as trap state. Okay. Now let us take one more example and you guys try to solve it. Okay, very good example it is. Let's have a look at it. Okay, now question number 2. Your second question is, were you writing that or that's fine if I proceed?
Yes, ma'am. Proceed.
What? Proceed, na? Okay. So your second question is, try to draw this or make an NFA, guys. So your second question is, construct a NFA that accepts sets of all strings over 0, 1 of length 2. Now here they have given which string, what is the input 0, 1, but in some questions it might be not given. So in that you have to assume that, or you have to consider that it is always 0, 1. Okay, this is given to you. Now how do we compute? Yes. So the question is, construct a NFA that accepts sets of all strings over 0, 1 of length 2. This is your question. And the same thing we had done in DFA. What was our DFA? We had constructed that, no? Similarly, you have to construct an NFA for this.
Ma'am, are we supposed to accept only these strings, or can other strings also be accepted?
Like which one?
Like, can we also accept strings of like length 3 and 4, but if this is accepted, then it's fine? Or do we have to accept only this and
Only
nothing else?
this. Yes,
Okay.
you have to accept, the NFA should accept only this because it is given in the question.
Then we'll have to make 3 states at least, ma'am.
Yes, very good. So I'll just draw, you tell me. We'll make 3 states, okay? A, B, and C. Okay, C will be my final state, okay? Now where to go? A to B, it gives?
A to B 0, 1, and then B to C 0, 1.
Very good, 0, 1, 0, 1. That's all?
Yes, ma'am.
Yes, you are absolutely correct. This is our NFA, which is proper. Now, if I were to convert this or to make a DFA, how it would go? It will be A, B, again 0, 1, and on C 0, 1. I will show one more state which is called my dead state if it was a DFA, right?
Yes, ma'am.
Okay, now we have properly constructed our NFA. Now let's see now so always remember that every time when you create an NFA or a DFA, you have to check whether that is working or not working. To check whether that is working, you have to take few examples and show both accepted state as well as not accepted state. Okay, now let me give you one example over here. For example, you guys check for 0 0. Is it accepted or not?
Accepted, ma'am.
Yes, it is accepted. Let's see how it goes. Initially, I'm at A on 0. I'm going to B again on 0. I'm going to C. And yes, I reached my final state. So it is accepted. Therefore, it is accepted. Now, let me give you another example. For example, just check whether it's working or not. Take an example. 0 0 1. I have three values now. 0 0 1. Tell me, is it accepted or not?
No, ma'am.
Accepted.
Accepted? No, no, not accepted. It is not accepted. Why? Let us see some pictorial depiction of that. A, okay. On receiving the 0, I'm going to my next state B. Okay. Again, on receiving a 0, I'm going to my next state, that is C. C is my final state. Again, I'm having what? I'm having 1. Again, I'm having a 1. But over here, I do not have any 0 or 1 from the final state C. So it goes to which state? Null state, right? It goes to phi. And this is called as a, what it is
Dead
called?
configuration.
Yes, it's called as a dead configuration and it's not accepted. Therefore, it is not accepted since I'm not present in my final state because I do not have any input value 0 and 1. So it goes to null state. That's why it is a dead configuration and it is not accepted. This is our solution for this question. Is it clear, all of you?
Yes, ma'am.
Okay. So just note down. Are you noting down or you'll just watch the lectures recordings? That's also fine with me.
Noted, ma'am.
Okay. Now let us take one more example. Few more examples. There are lots of examples. Okay. So isn't this interesting? Okay, let's see. Okay, you guys try to do this now. L1, your first question goes this way. L1 is equal to set of all strings. L1 is equal to set of all strings that ends with 1. That ends with 1. This is your first question. Your second question is L2 is equal. So the questions can be anything. It can be framed in proper with proper justification and clarity. Sometimes it can be given in this way. So you have to construct a proper finite state machine, whether it is DFA or it is NFA. So second question is, for example, L2 is equal to set of all strings. Okay, now try to construct an NFA for this. Second question is L2 is equal to set of all strings that contain 0. This is your second question. Okay, just this first two. Okay, just try this first two. Then we will take more examples.
Done, ma'am.
Okay, so if it's done, let us see what's the solution for that. Okay, now tell me for your first one, what will be your NFA? How many states will I have?
2.
The question, yes,
2 states.
2 states, okay? A and a state B, okay. But the question is L1 is equal to set of all strings that ends with 1, right? So which value should I give here? A to B?
A to B is 1, and then
Yes.
self on A 1, 0.
0, 1. Yes, absolutely correct. This is your first NFA, which is correct. Okay. Now second one. Your second one will be, the question is L2 is equal to set of all strings that, so I have repeated this twice. Okay, set of all strings that contain 0. It says it's not ending or starting or ending with 0. It says that it contains 0. Na? It is saying that it contains 0. So that's what, so what should I do here? Initially, I'll send a 0 to B, right? To the next state B, and I can have 0, 1 to itself. Again, for B, I can have 0, 1 to itself, right? Is this correct?
Yes, ma'am.
Yes. Okay, now let's take another example. Your third question is L3 is equal to set of all strings. Your next question is L3 is equal to set of all strings that starts with that starts with 1, 0. This is your question. Try to construct an NFA, guys, all of you. Similarly, your fourth question is L4 is equal to set of all strings. L4 is equal to set of all strings that contain 0, 1. One more question I'll give you. L5 is equal to set of all strings. So guys, just have a look here. Here we are not computing the transition table and all, because the question itself is to construct an NFA. So just show an NFA. Okay, when it comes for 10 marks or something, then you have to show everything. A 5-tuple representation, the how it is denoted, what are the values of that 5 tuples. Then you have to show the state transition diagram. Similarly, you will also have to show the state transition table, and you also show the examples. Okay, if it is for 10 marks, you have to show everything, all 4, 5 this thing values of that. But when it comes for 2 or 3 marks, then you just have to draw an NFA like this. That's it. So next question is L5 is equal to set of all strings that ends with, okay, that ends with 1, 1. Okay, try to solve these 3 questions, and then we will stop for today.
Done, ma'am.
Okay, so tell me what's the solution for this, for your first one?
We need
Sorry,
3
third one.
states.
We will have 3
3
states. Yes, 1, 2, and 3, which is A, B, and C. Okay, now
Then A to B 1, B to C
yes,
0, and then self 1, 0 on C.
yes, this is your solution. Very good. Your next one, I'll draw it here. Fourth one, for fourth, how many states you will have?
3.
3 again. Yes, so that will be A, you have B, and you have C. Okay, from A to B it gives,
0.
yes,
B to C
B,
1.
Yes. What
And then
about 0, 1?
self both on A and C 0, comma 1.
Yes, absolutely good. Now, last one, fifth one. What will be the solution? How many states? Here also I require 3 states, right?
Yes.
A, B, and C. Okay, A, B, and C. Tell me.
A to B1, B to C1, and then self 0, comma 1 on A.
Yes, this is your final NFA for fifth one also. Yes, that's correct, and I'm glad. Nice. You guys are really understanding it. So this is so understood. This is the difference between NFA and DFA. In NFA, you did not had any epsilon moves, and similarly, you had to show both the transitions. You had to show where the both input goes, actually 0 and 1. But in NFA, you have epsilon closure. You have to compute that. So you have epsilon moves, and there is no compulsion of showing all the input 0 or 1. Okay. Accordingly, you can construct your NFA. Okay, so I think we will stop here, and in the next lecture we will see conversion of NFA to DFA. So in that we will see 4 5 examples of conversion of NFA to DFA, and then I guess the last part is remaining, that is the regular languages, right? Regular expressions. Oh yes. So next time we will see conversion of NFA to DFA, and we will also see some regular expression examples, and then we can complete this unit. Second unit will be done, and in the next lecture after that we will start with our third unit. So in our next lecture we will complete this entire second unit by just completing two parts of it is remaining, that is conversion of NFA to DFA, and you have regular expressions. Okay, so we will see few examples on this regular expressions, and then our second unit is done. Okay, so it will complete our unit number 2. Now, then after that, we can start with our next third unit. Okay, and before your UT1, I will give, I guess, yeah, I'll some material for this for you to study. So what all things you have to study, it will be mentioned in that. Okay, all of you just refer that before your exam. Is it clear?
Yes, ma'am.
Yes, ma'am.
Okay. So thank
Ma'am,
you. I will, yes.
ma'am, any tentative dates for the exam? Because many students are asking.
Yeah, for the exams now, it was supposed to happen in the last week of October, but right now we are not having the exact timetable, right? And exact dates are also not out. We'll have to check it out with Pune people, Pune campus. Okay, it's coming from there, na? So that's why once the dates are decided, we will inform you. Okay, respective GFMs will inform on their groups.
So, ma'am, mostly after Diwali, right? Because last week of October.
Yeah, I guess not. Most probably after Diwali only, because see, in the last week, if it was going to come, it would have come till now. But abhi tak kuch aaya nahi hai, so I think after Diwali only. Okay, so don't worry about it. Okay, let me take your attendance. So is that clear? It was supposed to happen in the last week of October, but till now there are no updates on that. So most probably it will be after Diwali only. Okay, I've taken your attendance, guys. Thank you. Take care. See you in the next
Okay, ma'am.
lecture.
Thank you, ma'am.